Happy Tuesday, scholars, and happy crazy hair day or wacky hair day. I tried my best to participate. I'm sure some of you have some much better wacky hairstyles rocking and rolling right now. So today on Tuesday, we're going to shift a little bit. We were working on our addition and subtraction strategies for the past week, and now we're going to get a little bit more into multiplication. Just as a reminder, I want you to try to remember our cheer for what multiplication means. See if you can think back. See if I do like this, if that might remember, if might jog your memory a little bit, not just Miss Cupp doing some crazy dance moves. Thumbs up if you've got it. If you are thinking that multiplication is when we add the same number over and over and over again, go ahead and kiss your brain. If you didn't know that, that was a chant and a cheer that actually, I think now a fifth grader from VCP came up with themselves. You know how we can always be making up our own cheers to help us remember all of our important math content. So multiplication is when we add, or smart mathematicians know we can skip count by the same number over and over and over again. Go ahead and get your hands up. Do that over and over and over again. We know that if we count by a certain amount of times, then we can get to our product. You're going to see me use the word product. You're going to be reading the word product a lot. I want you guys to remember a product is just a fancy word that mathematicians use to describe the answer to a multiplication question. So if you see 6 times 3, the product is the answer to that multiplication question. I also want to remind you guys, good mathematicians, they don't always read that multiplication sign, the little x, as times. They always think about that as groups of. They always think about that as. They always think about that as. Yeah, they always think about it as groups of. So instead of saying 6 times 3, I know I'm a smart VCP mathematician, and I'm going to think, that actually means 6 groups of 3. Just want to give you guys those quick reminders as we get into our lesson for today. Alrighty, my friends, so to find our form for today, I hope you went, otherwise I don't really know how you would have found this video, but we're going to go to April 7th, we're going to click on multiplication review, and you're going to notice there's actually only, or I hope you notice, there was actually only one thing to click on. I know that the past week was a little bit confusing with so many different things to be clicking in and out of, and I hope you guys appreciated that yesterday we only had this one form, but Miss Hayes and I, we've always got our thinking caps on, and we figured out we can actually put the videos into the forms, which will make all y'all's life easier. So hopefully you clicked onto this guy. You've already watched that routines video that was in the second section of the form. If not, I'm going to walk you through it just in case you go back and you're a little bit tricked. No big deal. So when we click on this, it opens up. You'll notice that there's a little bit new screen. And because we have a new form, I of course had to include a new picture of Miss Buffy. This is her, being a little upset that my teaching woke her up from a nap today, but thought I would change it up, trying to keep it fun and fresh for you guys. So we're going to type in your first name. So I'm going to type in like Buffy. If Buffy was completing this form, she would type in Buffy Cuppernall because that's her name. And she is a Hadley student apparently. And then she's going to scroll down. She's going to click next. Then she already went and she watched that number puzzles video. So she's going to enter some random number. So I know that the puzzle told us that the 3 rules were, who can remember who can beat me? Ooh, okay, I'm going to go ahead and actually watch it to just make sure that we know what the clues are. I'm going to fast forward so I can see the clues. All right, even number. Okay, so it has 3 digits. It's an even number and is greater than 100. So I know any number greater than 100 is going to have 3 digits, right? Because we'll have a hundreds place, tens place, and a ones place. I'm thinking it has to be even. I'm going to enter in 102. If you entered in any number greater than 100 that was even, you got yourself a right answer, my friends. And then you clicked next. And then hopefully you found this video right here. Right now I just have a video from Miss Hayes holding the place, but you're actually going to be watching this video. If for any reason you had trouble loading this video, what I want to show you is you can click the play button and say yours is a little funky. You can actually click the YouTube icon right here. And if you click that, it opens it in a new tab for you. And then you should have no problem, or at least less of a problem loading it. So again, if you're having a problem watching this, or if at any point it starts like buffer or get weird, go ahead, click the little YouTube icon here and it'll put it into YouTube, and that might help you out a little bit. Just some handy tips and tricks. Again, my video will be here, not Miss Hayes. I just thought I'd use hers as an example. All right, let's get started with our content for today, my friends. So just as this will keep playing as you scroll down, so go ahead and feel free to scroll down. So now it's time to actually get into our review for multiplication. Hopefully a lot of this sounds pretty familiar to you, but if not, I still want you following along because we know that we have to make sure that we get this nice and strong before we can get into the spicier versions of multiplication later on this week and so on throughout the year. So I thought we would start with a CGI problem, something we're a little bit used to. So we know Mr. Cody, he loves to go on hikes, right? We talked about it in some of our story problems last week. He might have talked to you about it in class. So we know that he likes to go on hikes. Apparently, he decided every time he goes for a hike, he was going to find 8 cool rocks to pick up to add to that awesome rock collection he has, right? So on every single hike he goes on, he collects 8 rocks. 8 rocks on the first hike, 8 rocks on the second rocks. It's the same amount every time. I want to know, how many rocks will he have collected after he goes on 6 hikes? So one more time. Mr. Cody collects 8 rocks on every hike. We want to know, how many rocks will he have collected after 6 hikes? So I'm thinking, what is this problem actually asking me to find, right? There's lots of different ways I could solve it, but I want to write the number sentence to match the story first. See if you can beat me to it. I'm going to give you like 45 seconds. See if you can write the number sentence. I'm going to write it, but I'm going to hide it real quick with my video, and then I'll reveal it to you in about 40 seconds. What number sentence matches this hike? Remember, we talked about how multiplication means groups of. How many groups does Mr. Cody have? How many are in each group? Go. If you finish with extra time, because there is about 20 seconds left, write it in words too. What number sentence matches this story? I'm going to reveal it in 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. I hope that you wrote 6 times 8 equals R. And if you wrote it in words, which I actually wrote it in first because sometimes that helps me make sure I write my factors in order, I wrote 6 groups of 8 is the same thing as 6 times 8, because I know that times sign. This is the same thing as groups of. 6 times 8 equals R. So I know I have 6 groups because Mr. Cody goes on 6 hikes. And there's of 8 because every hike he gets 8 rocks. So I have 6 groups of 8 because every hike I get 8 more rocks. So let's go over some different ways we can solve this. I want you following along. So as my pen moves, your pencil or your pen or whatever you're using to write right now is also moving. I'm going to show you a bunch of different strategies. I really want you to pay attention to the skips counting strategy that I talk about, and there's a couple ways to do it. So the first thing that I know is the strategy that a lot of kids will start with is by drawing the picture first, right? They would draw their 6 groups. Maybe you draw boxes. I like to draw circles. So I draw my 6 circles, my 6 groups, and I put 8 into each group. Because this is multiplication, I put 8 into each group. So maybe I draw 8 dots. Maybe I do 8 tallies. Whatever you would like to do is what you like to do. I personally find tallies to be a little bit easier to count, but let's roll with circles for right now. So we'll do 8 in each. So there's 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 dots. Got a little sloppy at the end, my bad. There's 8 dots in each group. Now, some of you might want to count this like 1 dot at a time. That is an okay strategy, but I want to show you how to mark up your work so you don't get tricked and so that it helps us be a little bit quicker at picking up some more efficient strategies. So if I know there's 8 in here, I'm not even going to bother counting because I know there should be 8 in every group, right? So I know the next one I should count is 9, 10, 11, 12, 13, 14, 15, 16. Now I'm going to draw a 16 at the bottom of this because I'm totaling up how many I have. So I have 8 in here, then I go 9, 10, and I count on, and I end at 16. So I'm going to write that number at the bottom. Then I'm going to keep counting. I'm going to continue counting from 16. So this is 17, 18, 19, 20, 21, 22, 23, 24. So I'm going to write 24 because that's the number I end on. Sorry, I froze a little bit there. It's the number I end on. And now I'm going to come over here and I'm going to count this as 25. Yeah, because that's what comes after 24. So 25, 26, 27, 28, 29, 30, 31, 32. I'm going to keep going. So this is 33, 34, 35, 36, 37, 38, 39, 40. 41, 42, 43, 44, 45, 46, 47, 48. So I ended on 48. So that tells me 6 groups of 8 is equal to 48 altogether. So I'm actually going to go ahead and I'm going to circle that response right there because that is actually my answer. Now, some of you might also have been noticing that this pattern looks a little familiar. That's because it's also when you skip count by 8, this is the pattern that you're going to get. So if I skip count by 8, the way that some of you might be more familiar with marking this would be going like, okay, so if I know there's 6 times 8 equals R, I need to skip count by 8. How many times? 6 times, good. So you would go 8, then you might go 9, 10, 11, 12, 13, 14, 15, 16, 8 more, right? 17, 18, 19, 20, 21, 22, 23, 24. All I'm doing is starting with that next one and counting up until I have 8 fingers. 25, 26, 27, 28, 29, 30, 31, 32. 33, 34, 35, 36, 37, 38, 39, 40. 41, 42, 43, 44, 45, 46, 47, 48. Double checking how many times I skip counted. 1, 2, 3, 4, 5, 6. So, again, my product, my answer is 48. He has 48 total rocks. Another way we could do this is we could repeatedly add. However, I only want you to use that as a checking strategy today. So I only want you to solve this and solve multiplication as a checking strategy. Because I really, really want us to be using our skip counting strategies as we start to do some multiplication. Additionally, my friends at Hadley who know their 8 skip counting songs, which I can link to this assignment in case you forget, you could also be using your 8 skip counting song to help you solve your 8s, right? So you know that you can also sing the song to yourself. And once you have your 6 fingers up, because we know we need 6 groups of 8, then you know that you have hit your product. So that is a couple different ways that we can be solving 6 times 8. Since I told you that we can use repeated addition as a checking strategy, let's check to make sure that the product of 6 times 8 is 48 if we add 8 6 times. So if I come over here, I know 8 plus 8 equals 16. Then if I add 16 plus 8, I get 24. 24 plus 8. I can think about that as 24 plus 6, I know is 30. I know that there's 2 more I would have to add 8, so that's 32. 32 plus 8, I think about that as 2 plus 8 makes another 10. So I know that this is 40. So if I take the 2 plus the 8, that equals another 10, so that's 40. And then 40 plus 8, well, if I had 0 plus 8, that equals 48. Double check that I have 1, 2, 3, 4, 5, 6 8s. I do have 6 8s, and my product was still 48. So I know that is my answer. So again, there are some strategies that we can be doing. We can be drawing a picture and counting up on our picture, marking it with the total as we count up. Marking it with 8 in each would be kind of silly because it's doing a multiplication. So if you were somebody who was going like 8 and then 8 and then 8, well, I would hope there'd be 8 in each group. Multiplication is just adding this repeated addition, right? It's just adding the same amount over and over. So of course there should be the same amount in each group. Multiplication is adding equal groups. So instead, what I want you to do is mark it up like I did, where I'm marking up the total as I count along. We can also be doing our skip counting strategy as well. Then we can do our repeated addition, but that's really only to check for now, my friends, okay? So let's go back to our form and make sure we've entered in all of our information. Reminder, if you're watching this video, we should not be getting anything wrong on the guided practice portion of this form because I literally do it with you, my friends. So it's also a really good way for me to know that you're not watching the video all the way if we're getting some of these wrongs, okay? So how many rocks did he collect after his hike? He collected 48 rocks. Now, how does a mathematician read the multiplication sign? How does a mathematician read that? What do they read it as? They read it as what? A little louder? A little louder? Yep, they read it as groups of. They read it as, the multiplication sign is read as, it's read as groups of. So I want you to type in groups of. Anytime we see that time sign, I want you to read it as groups of. Get in that habit. Great mathematicians get in that habit early. I want you to be in that habit as well. What description, question 3, what description matches the story? We talked about this a little bit. I'm going to give you about 30 seconds. See if you can find the correct answer choice before I reveal to you what it is. What description matches the story? If you haven't clicked one, start thinking, which one am I going to click? About 10 more seconds. All right, I hope that you are thinking, yeah, I should have clicked 6 groups of 8. If you are following along with our scratch paper, we even already wrote it right here. Remember, friends, think smarter, not harder with that scratch paper. Great. Yeah, because it's 6 groups of 8. I have 6 groups of 8 rocks because Mr. Cody went on 6 hikes total. All right. Now what I would like you guys to do is I would like you to try this story problem with your own strategy. I want 2 strategies. Remember that first strategy? I don't want you repeatedly adding. I only want you to use that as a checking strategy for right now. I also can give you a hint for this strategy. I want you to think about, can we be using an array maybe, which we're going to get into more tomorrow, but I wanted to see if I can get your brains thinking on this. Can I maybe be using my knowledge of how to build an array to solve this problem as well? Going to give you guys about 6 minutes to solve it. In those 6 minutes, I want 2 strategies. Your first strategy needs to be something other than repeated addition. You can be drawing a picture. You can even be drawing an area model, maybe. You can be skip counting. Any of these are great options. That second strategy can then be repeated addition. All right, 6 minutes on my timer. I will stop the timer about a minute in just to double check that your number sentence is correct. I don't want you to go the full 6 minutes with an incorrect number sentence. But for the first minute, I do want you to try to at least get that number sentence down to match this story. So, Eli collects cans for a school recycling drive. So the school was collecting a bunch of cans to see how many they could collect, and he was helping. He collects 12 cans each day. How many cans will he have collected after 4 days? So Eli collects cans for a school recycling drive. He collects 12 cans each day. How many cans will he have collected after 4 days? I'll reveal the number sentence a minute in, but remember, 2 strategies to solve. Go. Alrighty, so I'm going to pause that timer to give you solving time. But what number sentence matches this story, my friends? How many groups do we have? How many are in each group? If you wrote, let me do the big reveal. If you wrote 4 times 12 equals C, or 4 groups of 12 equals C, go ahead and give yourself a big smiley face on your paper. You're absolutely correct. So if he's collecting cans for 4 days, that's how many groups he's going to have. Each day is a group. So he has 4 groups. The amount he collects each day is the number that goes after the multiplication sign, right? It's the groups of. He has 4 groups. Each of those groups has 12 in it. So we have 12 here, 12 here, 12 here, 12 here. All right, keep solving to find the product or the answer. What is 4 groups of 12? Remember, at least 2 strategies. I want you to be thinking, how can I solve this efficiently? That means quick but accurately. Ready? Keep solving. Right, if you haven't tried a second strategy, go ahead and make sure you've tried a second strategy to solve this. Remember, your first strategy should be something different than a repeated addition, but your second strategy could be repeated addition. You have just about a minute and a half left. If you have already solved this problem with 2 strategies, try another strategy. About just under a minute left. About just under half a minute. All right, pencils down in 10. Apparently this timer really wants you to know that it's almost over. 3, 2, and 1. That is our time. All right, let's go over a bunch of different strategies that we could be using to solve this problem. If you see me present a strategy that you haven't seen before or that you don't have on your paper, please feel free to give it a try as I follow along. All right, so the first strategy that many of you, I'm sure, might have used is to draw a picture. So I drew my 4 groups because I know 4 times 12 means 4 groups of 12. I drew my 4 groups, 1, 2, 3, 4. I put 12 dots or 12 circles in each one. Then what I did is similar to just like I showed you before, I counted them, adding up my total as I went on the bottom. So I know that the first one should have 12 in it. I'm not going to bother counting it because if it's equal groups of 12, the first one should be 12. But just double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now I'm going to continue counting after I've written 12 since at the bottom of the first group. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. And I did that until I got to the total of 48. So it seems that this product 48 I can get in multiple different ways. Apparently 6 times 8 works and also 4 times 12. Now, there's another way I wanted to show you how to draw this that might be a little bit quicker, because the issue with using this strategy is sometimes, say we get a little bit tricked and we don't put 12 dots in each circle. That means when we count them, even if we count them 100% correct, we still might get this wrong answer just because we didn't put 12 circles in each, 12 little circles or 12 dots in each group, which would be a super big bummer for you to do all of that work. So I want to show you another way when we're dealing with numbers like this that can help us make sure we're getting the right answer. Still using a drawing strategy, but it's just a little bit different. We know we love to use our tens and ones to help us keep track of double-digit numbers, right? We talked about that a lot last week. So why not use your tens and one sticks now? So I'm still going to draw my 4 groups. Here are my 4 circles. Can never seem to fit 4 in one row. No big deal. Now, how do I represent 12 in tens and ones? How many tens do I have? Look in the tens place. I have 110, right? So I know that in each of these groups should be a 10 stick. And how many ones? Look in that ones place. Yeah, 2 ones. So I can just draw them as tens and ones. So I'm going to go 10, 11, 12. 10, 11, 12. 10, 11, 12. 10, 11, 12. Now when I'm counting, this might help me count a little bit more accurately, right? And I can also break it up into an easier way to count. So first, maybe I count my tens, right? I go 10, 20, 30, 40. So maybe you can go like this, 10, 20, 30, 40. And then I can count 1, 2, 3, 4, 5, 6, 7, 8. I know 40 plus 8, why that's just the expanded form of 48. So using our tens and ones can be really useful to keep track of all of those numbers as we count when we're multiplying with double digits. Neat little trick. All right, another way that I would like to show you how to solve this problem is we can skip count. So I know I can skip count by 12s, but I don't know about you guys, but skip counting by 12s is a little bit tricky. So what can I do? I still want to use my skip counting strategy, but do I have to skip count by 12s to solve 4 times 12? I hope some of you are going, no, Miss Cupp, no, I do not. What else can I skip count by to solve this problem? So I know 4 times 12, that's the same thing. I know you guys talked about this in your array jar lessons. That's the same thing as 12 times 4, right? We know that if I flip the factors, I will still get the same product. I'll still get the same, Yeah, I'll still get the same product. Even if I flip the factors, I will still get the same product because if I built arrays, these would be congruent. We'll talk more about that in the next couple of days, but I did still want to show you the strategy, right? So I can still skip count by 4s. So I can either write it out and skip count by 4s in the writing way, Or I can maybe use my finger rolling songs for my Hadley friends. So we know that we can go PCP, good as gold. Let me see your fingers roll. 4, 8, 12, 16, 20, 24. That is how we roll our fours. 28, 32, 36, 40, 44, 48. La, 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 la. And then we know we go and put PCP singing. But if I have my 12 fingers up, what did I end on? I ended on 48, right? So I just did 4 times 12 on my fingers. One more time, we know. 4, 8, 12, 16, 20, 24. That is how we roll our fours. 28, 32, 36, 40, 44, 48. I know the last number I end on is my 12, right? That's because I had 10 and then 2. 48. So I can either do 4, 8, 12, 16, 20, 24, 28, 32, 40, 44, 48. And if I count this, sure enough, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, 11, 12. Sorry. I seem to have gotten a little mixed up. 1, 2. Silly Miss Cupp, she was so excited when she was writing out her fours by skip counting. She forgot to include one, so I just went and crossed it out. I'm going to do it one more time, a little bit slower to double check, right? So if I do my finger counting, if I do my skip counting or my finger rolling song, I know I'll go 4, 8, 12, 16, 20, 24. That is how I roll my fours. 28, 32, 36, 40, 44, 48. La, 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 la. PCP singing. Again, my Maryville friends, I will link the finger rolling for fours YouTube video, but my Hadley friends learned these songs. I'm going to have Mr. Cody be making some videos to help us learn our finger rolling song for Maryville, though. No big deal. I can also just generally skip count, whatever works for you. So I know that this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I got 48. It's a little hard to see, but I know that that is 48 when I skip count 12 times 4. So when I skip count by 4, it's 12 times. I get 48. I know that that is the same thing as 4 times 12. 4 groups of 12 is the same thing as 12 groups of 4. Another way I can think about to solve this is that repeated addition. So if I have 4 times 12 as my original one, right? I know that that means I'm going to add 12 4 times. So I can do 12 plus 12 equals. I can break this apart and think that about this as 10 plus 10 equals 20. 2 plus 2 equals 4. That's 24. So if I know 12 plus 12 equals 24, I can either then do 24 plus 12 and keep solving twice more, or I can think about this and I know that if I have 12 plus 12, I've added 12 twice and I got 24. I know I need to add 12 another 2 times, so I can think about this as 24 plus 24. I can use my doubles to help me solve a little bit quicker. I'm going to show you the first 2 ways. So if I do the normal way, 24 plus 12, I can think about this as 20 plus 10 equals 30. 4 plus 2 equals 6. That's 36. Then I know I have 1, 2, 3 12s. I need 4 12s. So I go 36 plus 12 equals 30 plus 10 equals, I'm just breaking it apart by place value. 30 plus 10 equals 40. 6 plus 2 equals 8. That's 48. Notice that that took me, sorry, y'all couldn't see me there. Notice that that took me a little bit longer. Instead, if I use my doubling method, I can go a little bit more efficient. I can go a little bit more faster. So if I know that I'm going to be doing 12 plus 12 plus 12 plus 12, well, I know 12 plus 12 equals 24. So I can come down here and I can say, I'm not going to caret it because that gets really messy, but I know that this is 24 plus, I know that this 12 plus 12 is also 24. So I can do 24 plus 24 equals 20 plus 20 equals, I think about that as 2 plus 2, which is 4. 2 tens plus 2 tens is 4 tens, that's 40. Think about that as 4 plus 4 equals 8. And again, we get 48. So I did the same thing. All I did was I used my doubling strategies to solve here. The final strategy that I want to show to you, I want to show you guys how to solve this problem. Since it's double digit, using our area models might be particularly helpful to solve this. Obviously, if you were solving the story problem, I would not expect you to show this many strategies. I just want to show you the huge variety of strategies that we can be using to solve a multiplication problem. You pick what is most comfortable for you. I might ask you to stretch your thinking and try something new, like how I'm asking you guys to only use repeated addition to double check your work like we just did. But I still want to just show you a variety of strategies because we can always be thinking about how to be more efficient. So a way to be using our area models to solve this is if I have 4 times 12, right? So I can put that on top. I know I can break 12 apart into something that is really easy for me to count by. What do you think that is? Show me in your hands. If you have 5, yeah, you're right. Counting by 5s is pretty easy, but I can also split it into 10, right? Which is, I can count super fast by. So if I split this length, right, I know I can break this length apart. So say I have 10. How much would I have left over if I take away 10 away from 12? Show me in your hand. 2. Yeah, good job. So I would have 2. So this length would be 2. So I can think about this as 4 times 10. I can think about the area of this as 4 times 2. My Hadley friends and I know that we can always be using our area models to be solving some more difficult multiplication and breaking it apart into things that are easier for us to multiply by. And I'm sure that my Maryvale friends also saw this with Mr. Cody as well as we were nearing that module season. So first I would do, what's 4 times 10? 10, 20, 30, 40. Yep. So I know that this whole area here is equal to 40. What's 4 times 2? 2, 4, 6, 8. Yeah. So I know my whole area here is equal to 8. Now all I have to do is add my areas together, right? Let's see if I get 48 again. 40 plus 8. Why, indeed I do. That's just the expanded form of 48. So we just did 1, 2, 3, 4, 5, 6 different strategies to solve this multiplication story problem. Obviously, I would not expect you to do these. I just wanted to show you how many different ways we can be doing it. If you're a friend who's over here using your pictures, I'm going to challenge you to skip count. I'm going to challenge you to be able to be trying skip counting. And then you can double check with your repeated addition or your counting. If you're a friend who's over here doing skip counting like this while they're drawing pictures, I want you to try skip counting like this. Skip counting where maybe we're using an easier number to skip count. Maybe we're inversing it and using the either number because we know our congruent number sentences will get us the same product. Then you can use your repeated addition. If you're a friend who maybe is rocking skip counting and you want to try using an area model and breaking apart your numbers into easier things to count by, be my guest. I just want you to be trying your hardest and trying the things that are comfortable to us, but maybe pushing our comfort zone because we know we always, when we stretch our brain, that's how we get smarter. Our brain is a muscle that we have to stretch and work it in order for it to grow. All right, my friends. So we know that Eli collected a grand total of 48 cans in his 4 days. So what you're going to do is you're going to click next. Now the independent part of your lesson is now in the same form, silent excitement. You don't have to go back and click a million things. Sorry about that. So these 4 problems that you guys have for your independent practice are very similar to what we just did. So if you're a little tricked, look at your scratch paper here for some clues, or go back and watch the parts of the video. You can fast forward through YouTube videos for some reminders. So again, today we talked about 6 different strategies that we can be using to solve some multiplication problems. They're all strategies that you've seen throughout the year. I just brought them into one video so that we all have what we needed. So happy solving on your independent practice. A finally friendly reminder. Once you click submit here, you are not quite done. And this will pop up once you click submit. So as a reminder, when you click submit, it will tell you this little blurb, great job, don't forget to click mark as done if you have questions. If you got tricked, you can go back and edit your response by clicking this link. Do not go back to the assignment and try to click it from there. You'll open a new one. Some of you have been saying my responses are missing. That's because you're not trying to edit your response. You're opening a new one every time. So if you would like to change something, this is what you click. It saves all your information. Once you click submit, it will take you here. You need to go back up to the classroom and you need to click mark as done. You need to click here. You need to click here, right here. Then your assignment will be complete. Additionally, somebody is being a little bit silly and they're signing in on the Hadley student account for the email and not their actual account. I can't give you credit if I don't know who you are. So please make sure that you're signing into your personal email account. If you're somebody who's using the HD student login to get into your computer or to get into the classroom, it's saving you as Hadley student. We don't know which Hadley student you are. Please, 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 please respond to the comment that I left so that I know who it is and how I can help you be making sure we're logging in correctly. But everyone else, make sure you're clicking here or else you're going to see missing instead of your grade. Happy solving, friends.